I am Dr. Phun. I know everything about acids and bases. Today, I will be your chemistry teacher.
So, what exactly is an acid? It sounds pretty cool.
An acid is a substance with a pH less than 7 on the pH scale. They turn red or pink when cabbage juice is added. Also, acids are sour. Examples include hydrochloric acid, nitric acid, and acetic acid. Acids can be weak or strong.
What about bases? Bases are just as important, right?
Yes, bases have a pH greater than 7. They turn yellow or green when cabbage juice is added. Acids are usually slippery and taste bitter like soap. Examples include potassium hydroxide, sodium hydroxide, and calcium hydroxide. Like acids, they too can be weak or strong.
Can I drink some of that acid? Oh, you've done it now.
Absolutely not. Both acids and bases have corrosive properties.
So, how many definitions are there for acids and bases?
Both acids and bases have two definitions. There are Arrhenius acids and bases, which either increase the concentration of H plus or OH minus ions in water. They can also be defined as a bronzoluric base or acid, meaning that can either donate an H plus or receive an H plus.
Okay, you didn't answer my question.
There are two.
Come on, Alfie, it's not that hard to understand. Then why are you turning so red?
Okay, class. That's enough with increasing the enthalpy. Come back tomorrow to learn about equilibrium constants and what you know and fun with K.
What is that saying? I don't know.
Hey Zach, how much do you want to bet I can squeeze blood from this piece of soap?
I'll bet you $10 if you can.
Okay.
That's why Vincent was trying to get 30%. What is it? 10%? It's not 10%. 10%.
This is what? Let me try.
Huh? That's 3%. Yeah.
What the heck? Nothing's happening.
I think they had a procedure on it. To get distilled with hydrogen peroxide? No, it's true. Well, let's ask if you can distill hydrogen peroxide.
What the heck? Why can you do it and I can't?
Because I'm just cool like that. Actually, what happened is before I came, I had a phenolphthalein acid, which is a weak indicator to my hand. And so when I touched the soap and started rubbing it, soap is a base, so it turned the phenolphthalein indicator pink, and so it looked like my hands were bleeding.
Welcome back, class. Now we'll learn about Ka and Kb. Did you guys do the pH?
Wow, that's so funny, teacher.
Yeah.
You see,
so funny.
I love it when I studied to the pH.
Oh,
I knew it. You guys never do the pH. No fast 40s for you.
Wait, what? It's right here. It's right here, teacher.
In that case, you're good students. And I guess I don't have to teach today.
Wait, what?
Wait, what? Where are you going? Get back here. Oh, whatever.
Well, we don't need him anyways. We know all about Ka and Kb and KSP. All the K.
Okay, let's do this problem. We have 0.1 molar HNO2 that is 6.5% ionized, so we have to calculate the Kb for HNO2. So first things first, we gotta draw a nice table. And you have to put the equation, which is HNO2 yields H plus NO2 minus. You have an initial concentration of 0.1 molar HNO2, and you have approximately 0 NO2 and 0 H plus ions. So next, since you have 6.5% ionized 0.1 molar HNO2, you have to subtract 0.0065 from this side and add that to this side. That is how much it's dissolving. And then what you end up over here is with 0.0935 molar HNO2 and 0.0065 molar H plus and 0.0065 molar NO2 minus concentrations. And now as for Ka, which is the equilibrium constant of an acid. And what it is that you take 0.0065 squared because you have two of these because it's the products over the reactants, which is HNO2. And so you do 0.0935. And then Ka equals 0.000452 molarity, or simply 4.52 times 10 to the negative 4. And that is Ka for this problem.
KB is just as easy, you will see. Let's try this problem. You're given 0.50 molarity ammonia, and you're given that Kb is 1.8 times 10 to the negative fifth. So we have to find the pH of the solution. So like always, you always start off by writing a mice table. So the equation is ammonia plus water yields ammonium and hydroxide. You're given that the initial concentration is 0.50 and you ignore water since it's a liquid, so it's not part of the equation, and the initial concentration of these is 0. And since you don't know the molar solubility, you assume that it's X. So this becomes 0.450, this becomes X, and this becomes X. And this is 0.50 because you have to assume that X is much smaller than 0.50. So when you're subtracting X, it doesn't make a difference. So after you find this, you have to say Kb is equal to this times this, the products, over the reactants. And you're given Kb 1.8 times 10 to the negative fifth equals x squared over 0.50. And then you multiply this by this and square root it to find x. And x is 0.0030. And this is the concentration of OH minus. However, the problem asked you for the pH. So after this, you have to do 10 to the negative log of 0.0030 to find the pOH. And this gives you 2.52. And your last step is subtract from 14 to get 11.4. And that's your answer.
This stuff is really easy, isn't it, Abby?
Yeah, it's a piece of cake.
But wait,
Whoa.
there's another more special K.
What is the special K you speak of?
It is KSP, and it is the equilibrium constant for slightly soluble salts.
Oh, that isn't even special. It works like any other K, doesn't it?
That's right. If you know Ka and Kb, you should master KSP too. See you tomorrow, children.
Okay class, today we're going to learn how temperature affects pH and equilibrium. I have two test tubes, each filled with water, ammonium, and a liquid indicator. I will now put one of the test tubes into the hot water bath and another in the cold water bath.
Would you actually
When we put this test tube into the hot water bath, it becomes lighter and more acidic, shifting left.
How long does the...
When we put it in the cold water bath, it becomes darker and more basic, shifting right. Now I will switch them to reestablish equilibrium.
I help you with the multi-part aqueous equilibrium problem, including the salt.
Now the lighter tube has become dark again, and the darker tube has become light again. Very nice.
What is a lover? No. It is actually a system of a weak acid or base and base or acid conjugate. It keeps a constant pH because of large amounts of both parts. For example, consider acetic acid in water giving both acetate and hydrogen ions. In this buffer system, adding hydrogen ions will shift the reaction left. However, the slight change will not affect the pH. Similarly, adding hydroxide ions will shift the reaction right, but it is important.
What is your example of a buffer, Dr. Shayla?
You are buffer, my friend.
What? I didn't know.
Your body has a bicarbonate buffer system, which helps keep the pH in your body between 7.45 and 7.35. If this buffer is broken by adding a lot of one side, it can result in acidosis or alkalosis.
Okay, now can we move on to something else?
Why yes, we will now discuss the part of antacids and placebos. Antacids are really important to well-being, since they help neutralize the hydrochloric acid in the stomach. If you're sick to the stomach, taking Tums will help neutralize the stomach acid and help you feel better. However, do you know that calcium carbonate, the main ingredient in Tums, isn't the only antacid? Stronger carbonates, magnesium hydroxide, and aluminum hydroxide are just as effective.
Oh, yeah, my parents forced me to ingest baking soda because they say it works just as well as Tums. They pull me down and stuff it down my throat.
Actually, baking soda is a much cheaper alternative to Tums. That's another problem. How much would a 1.81 kilogram box of baking soda cost if it were to be priced at the same rate as a 12-pack of Tums? A 12-pack of Tums contains 500 milligrams calcium carbonate per tablet and costs $1.25.
Let me try that. Wow, the baking soda is much more effective. You can rip out for so many years.
What's a placebo? You mean a placebo? It's like a lucky charm.
Well, what does that have to do with chemistry?
Placebo is often used in the testing of medicine. There's one group of people that take the real medicine, and another group that take a placebo, a fake substance that does nothing. However, they are all being told that they're beginning with the real medicine. If there is a significant increase of curing the problem in the real medicine group compared to the placebo group, that means that the medicine is legitimate.
Is mine a share of placebo? What about mine?
Yes, those are also placebos. Hopefully, they'll help you on home exam.
Oh snap, we have a big exam? Damn it.
Dr. Kaplan was validated back to college class with his more students of acid and bases. It is very nice.